Hello students, we are back to the channel with yet another video on trigonometry. So here we are going to understand about the identities. Earlier we talked about lot of ratios in terms of sin theta, cos theta, what is the value for each degree and how those values are derived. So if you have missed out on that, you can go for the previous video and look at how those ratios are derived and what are the values are corresponding to them. Now we look into the identities. So in order to crack higher level examinations, in the board examinations, CBSE board examinations as well as in Olympiads, so you have to know a lot of about what is the background concept behind each identity. So why an identity is formed, what is the logic, so that you can easily evolve a lot of problem solving methods in that, and your understanding will be great and you will have a lot of confidence to work on that. So here is yet another video about this. Let's get into the trigonometric identities, and it's mostly about how to understand these identities and how to use them further. We know this right angle triangle and these identities, the sin theta, the cos theta is equal to BC by AC. So all these we know. So we know the right angle triangle is there, that ABC is there. The Pythagoras theorem is always applied in the right angle triangle. So you could also note that in the last video which we saw, the values of sin 60 or sin 30, sin 45, sin 90, everything comes with the help of right angle triangle. So once you know about this right angle triangle rule, you can apply it to all the trigonometric ratios. So now that you know the formula of this hypotenuse AC square is equal to AB square plus BC square, let us derive the first and foremost and most famous identity, which is sin square theta plus cos square theta is equal to 1. So assuming this angle is theta here, so what I am going to do here is I am going to divide this angle by AC square. So let us check what's going to happen. This thing becomes AB square by AC square plus BC square by AC square is equal to AC square by AC square. Okay, got it? We also know one thing, that AC square. Okay, now what happens here is AB by AC the whole square plus BC by AC the whole square is equal to AC by AC the whole square. So it's understood that in this particular triangle, you see that AB by AC is sin theta, here is AB by AC, and the adjacent side BC by AC is hypotenuse, this is hypotenuse square, and AC by AC square is 1. So there is no need for confusion. Now we can write sin square theta plus cos square theta is equal to 1. This understanding is very important in solving any type of competitive exam question, or per se your board exam question in 10th standard, where you are expected to prove a lot of things in the the chapter 8.3. It's completely about proving the different identities. Don't have to worry about it. Once you are very sure about the identities, it will be fun to solve all those problems in this. Believe me, it's a fun to solve in the exercise 8.3. So let's go to the next one. As you might have guessed, so what we can do is here we divide it by AB square. When I divide it by AB square, this becomes AB square by AB square plus BC square by AB square is equal to AC square by AB square. BC by AB is cot. You can check the previous slide, it is cot theta. So it becomes 1 plus cot square theta is equal to cosecant square theta. So this for 1 plus cot square theta is equal to cosecant square theta. So here let us see what to do. Now I am going to divide it by the last one we have, which is BC square. Divide by BC square is equal to AB square by BC square plus BC square by BC square is equal to AC square by BC square. So let us check what is going to happen here. So AB square plus BC square is tan square theta plus BC square by BC square is 1, and AC square by BC square is what? Is secant square theta. So this is the inverse of cos theta, so we get this 3 values. And hence if you see, I have to summarize all the trigonometric identities. It is sin square theta plus cos square theta is equal to 1, and 1 plus tan square theta is equal to secant square theta. Cot square theta plus 1 is equal to cosecant square theta. So this is what we have derived. Roughly if you see the workings, you can understand what we have derived. So you just keep in mind, and then we can go to the other solve one of the problems in this, so that you can get a better idea. So this is one of the problem in exercise 8.3 in your book. I took it because it's quite interesting, because it involves some more logic. So let us see what. So now we have to prove the left hand side is equal to right hand side. Okay. Now let us take L, H, S and solve. Okay, and prove that it is equal to RHS. Okay, let us do it. 1 plus cosecant square theta minus cot square theta is equal to 1 minus cos theta by 1 plus cos theta. So let me expand this here. Let me expand this cosecant square plus cot square theta minus 2 into cosecant theta into cot theta. Okay. Now if I expand this more, I can get 1 by sin square theta plus cos square theta by sin square theta minus 2 into cosecant square theta is 1 by sin theta, and cot theta is cos theta by sin theta. Now what happens is 1 by sin square theta plus cos square theta by sin square theta minus 2 into cos theta by sin square theta. Here you can easily take this sin square theta as the denominator. Okay, sin square theta, 1 plus this becomes cos square theta minus 2 cos theta. Okay, so does something click to you? What is the meaning of this 1 plus cos square theta minus 2 cos theta? Does it click anything to you? It is nothing but 1 plus a plus b the whole square. See, if I apply this a plus b the whole square to 1 plus cos theta the whole square is equal to 1 square plus cos square theta minus 2 into cos theta, right? This is the equation for this 1 plus cos square theta. So you have to deduce certain things with the help of algebraic identities and with the help of trigonometric identities. So all these things are understood by you. So only when you solve a lot of problems, you have to anticipate certain solutions from this. Okay. So, and secondly, this sin square theta will be converted into 1 minus cos square theta as per trigonometric identities. So let us solve this and complete this within a few minutes, because it is not a big problem, so we should not take much time here. Let us solve this completely. So this becomes 1 plus, 1 minus cos square theta divided by 1 minus cos theta the whole square divided by 1 minus cos square theta. Now this 1 minus cos square theta can be written as 1 plus cos theta into 1 minus cos theta, and here the numerator is 1 minus cos theta the whole square. So here I can cancel this 2 by cancelling this, and moving on further we can say that 1 minus cos theta by 1 plus cos theta, so which is equal to RHS. So combination of trigonometric identities and algebraic identities are used here, so you have to anticipate it as I told you. There is another thing which we want to discuss today, because you have to know how to express one particular identity in form of any other identity, because that is how you can solve various type of problems. Such type of problems are also asked. So let us see that explanation for one particular such case. It's a table, okay, and usually the x-axis consists of other things, and y-axis also there are a lot of other aspects. So but here what we use is only one thing, where sin theta, we take sin theta and express it in the ways of other identities, so that it will be easy for you. Okay. So the first case here is about cos theta. So you know the trigonometric identity which is there for cos theta, which is 1 minus sin square theta. So 1 minus sin square theta is equal to cos square theta, right? So if I take root of this, what will I get? I will get cos theta, right? So the answer for this is root of root of 1 minus sin square theta is cos theta. Alright. Now for tan theta it is sin theta divided by root of 1 minus sin square theta, because we have already proved here, right? We have already proved here that sin theta in form of cos theta is 1 minus sin square theta. So similarly cosecant square theta is easy, 1 by sin theta. So secant theta is cos theta by sin theta. So sorry, 1 by cos theta, which is 1 by root of 1 minus sin square theta. Then cot square theta is cos theta by sin theta, which is inverse of tan theta, which is root of 1 minus sin square theta divided by sin. So this you can apply for any particular thing and you can solve it here. Various identities. So you have to construct the table. Once you construct the table, you will be easy to solve. So after watching this video, take a paper and pencil and try to solve all the ratios and put them in the form of this x-axis and y-axis. You try it again and you can easily find out how these identities are coming in form of each other. So what is the benefit of doing this table? See, while solving any problem, if you just note down this as a table and look at all those values, you can easily understand any problem. So here if I say sin theta can be represented in the form of tan theta by sin theta by 1 minus sin root of 1 minus sin. So this particular part, when it comes in any problem, you can solve it very easily. So you have to see such important values so that you can solve in the actual examination. So that is the benefit of this table. And if not for solving, you can just get at least an idea that you have to go through this way to solve this particular problem. So this is how it works with the identities. We started with the right angle triangle rule and how it gives out lot of sin values as well as cos values in terms of identities. So this is the power of the right angle triangle. So it has given us first of all the ratios, then now it gives the values of all the identities here. So, once you understand this, you can easily solve any type of problem in the exam. So, that is the purpose of this video. So, keep looking at our channel for more updates and to understand more about the concepts. Thank you.